Thanks very much. Well, in the interest of not getting between you and, drinks or something, I'll set a land speed record for slides. We're not really a startup. We've been doing this for over a decade, so I thought I'd start by just telling you our story and really start with a question, which is, why would you think about building an Internet of Farming things? We've talked about a lot of this already. But essentially, Australia is a very significant producer of agricultural product, $50+ billion annually. That's increasing, and represents a significant opportunity globally. There are a very large number of farms, and many of them need help. And we've already talked about how important it is for our regional areas to have a focus on economic viability, and we have to make sure that that continues to be true in the future. Interesting fact that Australian farmers are recognised globally for their levels of productivity, and we are a significant net exporter of product. Each farmer roughly feeds 600 people, 150 of those in the country, 450 outside the country. So being an exporter of product is obviously significant to our economy. It's only 3 or so % of GDP at the moment, but we certainly expect that will increase. But we know that the world population is growing. And so looking at world food requirements clearly is an interesting opportunity. And we've talked about this massive productivity challenge that sits in front of agriculture. I think that equates to a productivity level of at least 2% a year, and I think the batting average at the moment is less than 1. And so it's a very significant ramp up from where we are, and information technology clearly is widely considered to be important. Another very significant factor, in addition to the importance of soil, is the importance of water as a highly contested resource. Globally, and it varies a lot in lots of parts of the world, but agriculture uses up to 70%, and by some figures even more, of available water. Now, if we are to, if you draw a straight line on that 50 to 70% increase over the next couple of decades, that's a 50% increase in the use of water again, which clearly is impossible. We've also talked about the availability of arable land, and in fact, the fact that it's becoming less available. So what that ultimately means is that all of the productivity growth has to come from yield and productivity improvements. There's no more land, there's no more water, and so that's where the challenge is. Right, and interestingly, from the FAO's point of view, they see 50% of the total productivity improvement required to meet that challenge coming from irrigated agriculture, so more pressure again on water. Technology obviously has played a big part, and depending on what technology you talk about, through the green revolution, obviously genetics and biologicals and mechanisation and all these sorts of things, most people now think that information technology holds the key, and that certainly is true. In the Internet of Things, as we've discussed, with this ability to capture large amounts of data and provide that for improved decision making, and importantly automation. All of these create very interesting challenges. We've talked about the opportunities for being able to understand what's actually going on, rather than the perhaps sometimes skewed samples of just looking at the parts of the property that you happen to be covering yourself. And this ability, notwithstanding lots of challenges, of being able to put the information into the hands of the people who need it to make better decisions on a day-to-day basis. Ultimately, to drive decision-making based on data. So one small example, in California at the moment, even though there's been a bit of rain and it's still considered to be in drought, in its 5th year of drought. In California, less than 15% of irrigated farmers use any kind of technology to inform their irrigation decision making, and yet Pacific Data Institute concludes that a single soil probe and weather station used to inform that decision would yield a 30% water efficiency improvement and a 5 to 8% yield bump. Right, so clearly something has got to be done when you're in a state like California, which, in addition to the water saving, you've got the energy saving. This is a state that regularly blacks out when its grid can't keep up. Electricity pumping demand for irrigated pumps in California constitutes 7 to 11% of grid load in peak times. So the nexus between energy, water, and available land is a very rich, fertile ground for applying technology. Clearly we need to improve yields. Clearly we need to talk about labour productivity. Certainly in many parts of Australia it's a big deal. We also work a lot in California, and historically people have considered it not to be a problem in California, but these days it most certainly is. And availability of labour is becoming a significant factor there as well. And clearly, lowering general costs, but also managing and tracking and controlling inputs. Again, because California examples have come easily to my mind. There are many parts of California where complete accounting of all nitrogen inputs to the farm are a precursor for being able to grow the same crop in the same area the next year. So you're talking about freedom to operate, you're talking about obviously provenance and supply chain. So this need for information and also responsible use of inputs will only increase. So we all agree it's a great idea. We thought it looked like a good idea more than a decade ago, even though it wasn't called anything like this. So what does it actually look like? Our view of what it looks like obviously is getting stuff out into the field and measuring and controlling everything relating to water. But it's important to understand that the challenges that we've already talked about in terms of getting technology into this environment are significant. People don't always think all that carefully about where they're going to put your product. You're subjected to very significant extremes. And generally speaking, farms aren't very nice places to put technology. I'm not getting another slide here. Conditions can change rapidly. Water can appear where it wasn't, and the challenges of keeping electronics running can be very significant. Water extremes, temperature extremes, all of these things make it very challenging. We've talked about the challenges of just getting basic connectivity and needing to manage wireless networks. Here is a map of most of the units that are deployed on our network in Australia. There's over 5,000 dots on that map, and if you overlaid that with a Telstra coverage map, I think you'd find a lot of the dots not within those areas. So needing to be able to build and maintain networks out of all sorts of different technologies is very significant. Power management obviously is a big problem. This is something that Chris alluded to, which is that this technology has to be absolutely robust. When we talk about our products and when our engineers work on our products, we want them to think of it like a satellite, that it's never coming back. As soon as somebody has to put a footprint on a farm, to drive a truck somewhere, to go pick something up, boom, like everybody's money's gone. And so reliability and all the things that wrap around that ecosystem are absolutely critical and shouldn't be underestimated. Just simple things like ease of installation and who could be trained up to install a product and how they're going to know they've got everything they need to install that product successfully. The most simple and straightforward things can often get in the way. And so thinking about how products are packaged and how they're documented, and the fact that, in addition to all the cool technology that we love thinking about so much, that in actual fact, just an Allen key, and a simple one-page sheet of instructions might actually be really important and be the difference between your customer being able to install that product themselves and not, in the 15 minutes that they're going to have available. So, just the IKEA style, and I'm sure everybody in the room has a variable experience with getting to the end of the IKEA thing and finding 2 screws left over and thinking, oh, well, it's still up, so it still works. But the fact is that level of simplicity and the training requirements, again, Chris talked about that, these products have to be appropriate for the ways that they're used. Obviously, it's a matter of bringing a lot of different things together. In our case, a cloud-based platform that covers a wide range of scenarios around water use and water management. Very significant amounts of data that we capture now, in Australia and many other parts of the world. Ultimately, with a view to presenting it in a way that can be made, simple decisions can be made from starting from simple sort of fuel gauge style indicators all the way through to a deep understanding of what's happening and the relationship between the atmospheric conditions and evapotranspiration potential and subsurface soil moisture. Importantly though, in addition to the grower, we have to also support the channel that the products are sold through. So there's not 1,000 people in Observant trucks driving around the country. We have a national network of dealers. And again, to Chris's point, I needed to record that and use it in my sales literature. The point is that, you know, we have to be able to train people up to support these products. And these, you know, we have customers who have products that are still running 10 years later. In fact, somewhat to our detriment, you know, our software has to continue to be compatible with all of the products that we've shipped up till now, and our channel has to keep supporting them, and those products keep running. So being able to support is just as important as being able to build. And ultimately for us, with the objective of focusing on the precision application of water and its role in driving productivity in agriculture. Thank you very much.